Deep Learning Basics, Neural Nets to Transformers. Welcome to this beginner first lesson in the AI for Beginners Foundation batch. This session is designed with you in mind, intuition before jargon, no code before coding, and clear mental models over formulas. Here's how to get the most out of this lesson. Pause to try micro exercises. Keep the provided checklists and revisit timestamps for review. By the end of this session, you'll have a rock solid foundation to understand how AI actually learns and how the models powering tools like ChatGPT, Midjourney, and Google Gemini work behind the scenes. Segment 1: Neurons and Layers. What you'll learn. Neurons as basic decision units, activation functions, and non-linearity. Why stacking layers creates intelligence. Explanation: a neuron takes input, applies weights, adds bias, and sends it through an activation function. Alone, it's simple, but stacked, it becomes powerful. Example: sorting emails into work versus personal. The neuron learns word patterns and predicts the category. Micro exercise. Pick a task in your life, write its input, process, and output. Pitfalls, overfitting, privacy leaks, misclassifications, ethics. Ask: could any group be harmed? Do we have consent? Quiz. Training accuracy high but test accuracy poor. What's happening? Answer: overfitting, mini recap, inputs, patterns, labels, generalization. Segment 2: Training deep nets. What you'll learn: backpropagation intuition, gradients and learning rate, initialization, explanation. Training is feedback driven. The model adjusts weights step by step using gradients. Example: learning guitar. Each mistake adjusts your fingers. Micro exercise. Think of a skill you're learning. Map feedback plus correction to your practice. Pitfalls. Learning rate too high, chaos. Too low, no progress. Ethics. Biased training, unfair models. Quiz. Model not improving at all. What's wrong? Answer: bad learning rate or initialization. Mini recap: weights, gradients, learning rate. Segment 3: CNNs, convolutional neural nets. What you'll learn: local patterns, pooling, image tasks, explanation. CNNs detect edges, colors, shapes, combine them into larger patterns. Example: your phone detecting a face. Micro exercise. Look at an object. List 3 small features CNN would notice: edges, textures, or color. Pitfalls. Fails on rotated or unseen images. Ethics. Face recognition misuse. Quiz. CNN works on cats but not dogs. What's wrong? Answer: biased data set. Mini recap. From pixels, patterns, recognition. Segment 4: RNNs, recurrent nets. What you'll learn: sequences, memory, vanishing gradients. Explanation: RNNs process text or sequences step by step, but struggle with long-term memory. Example: predicting the next word. I love pizza. Micro exercise. Predict the next word in a short sentence. Pitfalls. Forget long context. Ethics. Can reproduce biased or toxic text. Quiz. Why don't RNNs scale well to long text? Answer: vanishing gradient. Mini recap. RNN equals memory but limited. Segment 5: Attention and Transformers. What you will learn: attention mechanism, encoder, decoder, scalability, explanation. Attention focuses on relevant words. Transformers scale this with parallelism. Example: reading a paragraph, you only focus on keywords. Micro exercise: underline only the important words in a passage. Pitfalls: high compute costs, ethics, energy usage, bias amplification. Quiz: what's the biggest innovation of Transformers? Answer: parallel attention. Mini recap: attention equals focus. Transformers equals foundation. Segment 6: Embeddings. What you'll learn: dense representations, similarity, transfer learning, explanation. Embeddings map words or items into numerical space. Similar things are close together. Example: word 2, vec, king, man, plus woman, approximately queen. Micro exercise: pick 3 hobbies. Imagine each plotted in space by similarity. Pitfalls: embeddings can capture bias in data, ethics, gender or racial stereotypes can creep in. Quiz: if doctor is closer to man than woman in embeddings, what's happening? Answer: biased data. Mini recap: embeddings equals meaning in numbers. Segment 7: Transfer learning. What you'll learn: pre-trained backbones, fine-tuning, freezing layers, explanation. Instead of training from scratch, reuse pre-trained models like learning Spanish after knowing Italian. Example: use ImageNet trained CNN and adapt to detect plant diseases. Micro exercise: think of a skill you built on a prior one. That's transfer learning. Pitfalls: overfitting on small data sets, ethics, using open models responsibly. Quiz: why is transfer learning powerful? Answer: saves time and resources. Mini recap: reuse knowledge, faster progress. Segment 8: regularization and tricks. What you'll learn: dropout, batch norm, data augmentation, explanation. Dropout removes random neurons during training. Batch norm stabilizes learning. Augmentation expands data artificially. Example: flipping images of cats to double dataset size. Micro exercise: think, how would you create variations of your daily tasks? Pitfalls: too much dropout slows training. Ethics: synthetic data must still respect privacy. Quiz: what's the purpose of dropout? Answer: reduce overfitting. Mini recap: regularization equals safety nets. Segment 9: compute and data. What you'll learn: batches and epochs, GPU TPU basics, data size versus quality. Explanation: batches equals small groups of data. Epochs equals full dataset passes. GPUs accelerate matrix math. Example: cooking analogy: batches are small meals. Epoch equals cooking whole menu. Micro exercise: think of a repetitive task you repeat multiple rounds. That's like epochs. Pitfalls: bigger data is not better if quality is poor. Ethics: energy costs of massive compute. Quiz: if model trains fast but poorly, what's missing? Answer: high quality data. Mini recap: data plus compute equals foundation. Segment 10: frameworks. What you'll learn: PyTorch and Keras, high level APIs, no code paths. Explanation: frameworks make deep learning accessible. No need to reinvent the wheel. Example: Keras equals LEGO blocks for AI. Micro exercise: check one no code tool like Teachable Machine or Runway. Pitfalls: framework lock-in. Ethics: beware black box risks. Quiz: why use frameworks? Answer: simplify building. Mini recap: frameworks equal shortcuts. Segment 11: case study, plant disease classifier. What you'll learn: real world dataset, transfer learning plan, evaluation metrics, explanation, use pre-trained CNN, fine-tune for plant images, evaluate with accuracy, recall, precision. Example: farmer uploads a leaf photo, system predicts disease, micro exercise. Think of a domain you'd apply AI to. Pitfalls: data imbalance, ethics, critical use, farmers' livelihoods depend on accuracy. Quiz: if recall is low, what's happening? Answer: missing positive cases. Mini recap: case study equals theory to practice. Segment 12: action plan. What you'll learn: small vision task, pre-trained model use, documentation, explanation. Start with small tasks. Use pre-built models. Document results. Example: classify 10 categories of fruits with free Colab notebooks. Micro exercise: pick a personal data set, even 20 to 30 images. Try classification. Pitfalls: starting too big. Ethics: respect data rights when collecting. Quiz: why start small? Answer: builds confidence and avoids overwhelm. Mini recap: small wins lead to mastery. Today you've learned neurons, CNNs, RNNs, transformers, embeddings and transfer learning, regularization, data, frameworks, ethics and pitfalls, a real case study, and your action plan. Next steps: grab the free resource pack, try the guided exercises, subscribe to grow your life with AI, comment AI, and claim your free AI Beginners Resource Kit.